Hey, how's it going? I'm Luke here at Covalence, and we're answering a student's question. Now, while I conversed with a student in DMs the other night about, answering this question, make sure they didn't have to wait the entire day for me to record a video, get it uploaded, and put on YouTube for them, they asked a good question about the fundamentals of what is a route and how does it kind of tie into Express and Node. So, this is going to be taking the answer I did in text for the student and turning it into a video. So thanks for the fantastic question. We have a lab in our full stack curriculum in the Node and Express sections in particular that says it needs to create a route that reads a file and responds with the results. But what does that mean exactly? Respond in what way? Where do I see this route or how do I interact with it? At this point in the course, this is their first time building a Express application, and we're not building anything particularly advanced. The lab has you build a form and display that, being able to add results to that form and display the results underneath the form somewhere on the page. It doesn't have to be super fancy, but basically it deals with simple get and post requests, which we'll talk about those in just a moment. So based on this question, I figured we'll code something very easy and very simple to introduce the concepts of Node, Express, and what routes are along the way. So I have no directory ready to go yet, so we're going to go ahead and start with the utter basics of making a new directory. We'll call it node fun. I'm going to cd into said directory and go ahead and run my npm init-y to go ahead and make this into a Node project, which obviously you probably already have installed if you're curious about what Node is. It's nothing more than a JavaScript runtime that allows us to write server-side tools and applications, okay? And my barrage of DMs to the student last night, I talked about what a server is. It's just a computer that is running this thing. That's all it is, right? It's a computer running something that we can somehow talk to via the web, which we'll talk about when we get to Express. That's all Node is. It's JavaScript that runs on our computer, which means we can now be interacting with hard drives, databases, files on, I mean, technically that's part of the hard drive, like files on our computer. We can now read and write to them via JavaScript code, which is super cool because so many people build JavaScript web-based applications, things we see like in Chrome, any website we go to, or even things like Electron, which is using JavaScript code to write what look like desktop applications. For example, Spotify or Discord are Electron applications. They're just JavaScript and a lot of times React as well that are running in a disguised Chrome browser, right? So everyone knows tons of JavaScript code for the client side, but there wasn't really a good solution for the server side, hence why Node was released on Linux in 2009 as its goal. We already all know JavaScript. Why can't we just use JavaScript to write server-side applications? After Node was invented, I know NPM came along the way like in 2010 or something like that, and everything went to Windows and beyond in 2012. I can't remember the exact dates. I should have written them down. I was like reading about like the history of Node on Wiki this morning, to kind of give some history and context to this answer of what is a route, which I like how we're like, we have to first create the universe before I can define what a route is. But yeah, like that's when it all started out. So it wasn't, like a decade ago at this point, or a little over a decade ago at this point, but it's cool to know that's where it came from. That's what its purpose was, right? So by itself, installing Node, you've gone to the Node.js website, you have it installed probably on your machine, and you can open up whatever terminal you want to use. I'm here in Commander, and yeah, running npm init-y in a directory gives you a package.json file and the ability to now use npm to install packages, the beauty of this system, right? This ecosystem. So by itself, we can actually make a server that will automatically run just with vanilla Node code. And this is something I didn't expand upon to my student last night, but this is important to know as I've had alumni that have applied for server-side positions and they say they have Node experience on their application and they're asked to make requests or server-style code strictly from Node, which is totally doable. And yeah, we can actually make a very simple server here where we can import and use the HTTP library. This is also how you would write requests with Node itself. If you were not allowed to install libraries, you would have to use HTTP dot and make requests from there, right? So this HTTP library is automatically built into Node for us. It's similar to things like path and file system. They're just core modules for Node to do just like basic server-side tasks. So what we can actually do is we can build ourselves a server here. by running the create server function. It's going to take an anonymous function. You can use function or arrow syntax, doesn't really matter. We'll have our requests and our response, and it'll be, well, I guess pretty simple, right? We'll say res dot, and we'll have a write head here, I think. That's what we need. Yeah, sends a response header to the request, right? So basically, we are writing the headers of our requests. Think of them as like ultimately an object of key and value pairs that just kind of tell our browser or whatever we're doing or wherever we're making requests from that, hey, here are some options, configurations of this response, right? We're saying, hey, set up this response to have the following headers. If you imagine the response as kind of like a JavaScript object, because ultimately that's what it parses out to in our code, we are saying, I want to write a header that has a status code, and I think we can provide additional arguments, status code, and a message. Okay, so the status code is required, and the message or what kind of headers are outgoing, these are all options here. So if you don't know TypeScript, that's what this IntelliSense thing window here is telling us. I was looking at the arguments and their types here. So this is like kind of a way you can glean some information, right? So basically we're saying this has like a status of 200. That's where that status code is going to come into play. And we can also set, hey, this response is also coming with some additional information, right? So if this is our response, it has a headers object, and inside of that headers object, we can define something like this: content-type applicate, or actually be text/plain should be what we're doing here. So basically, this is kind of what we're doing. This is our response object. It has a headers object that we're adding to it right here, where we're saying, hey, content type text/plain. So that's what we're doing right there. I like how my auto formatter switched it from double quotes to single quotes. That's my preference. But yeah, basically what we're doing here is we're telling our response from our server that we're coding here that I'm going to have this kind of status code when making this request, these kinds of headers when making this request, because they're going to send a response that has some plain text associated with it. So again, we have to kind of tell our browsers or wherever we're making this request that, hey, this is the kind of content coming with this response, right? So that's what we're doing by doing this write head. And then we can say, end this response by writing the following. Wow, this is cool! Exclamation point. We're going to change it up from the classic hello world. And then from here, all we have to do is tell our server to listen on a particular port and host name, if I'm not mistaken. The host name is optional. I think it'll default to localhost. We'll see. The port is even optional, and it should also probably have a fallback of some kind. But we're going to play it safe and provide a port for it to listen on here. We're going to say sit on port 3000. And from there, I would like you to just let me know that the server is running. So I'm going to write a console log, server running on port 3000, exclamation point, because we're super excited about this for some reason. But that's as simple as it needs to be. And again, like for this student that asked the question, anyone else out there, this is all just vanilla node code. I haven't installed anything. This is how you would write and build a server that can take responses and all that kind of fun stuff. And to run this project, we're going to simply go and run node on the server.js file. It successfully told me server running on port 3000, so we know it's now running. Now, one of the questions that the student asked was, well, how do I really interact with it, right? How do I do that? Well, we're going to open our browsers, and we're going to navigate to a website here by localhost :3000. So if I navigate here and hit enter on the URL bar, check it out. We got the response text of, wow, this is cool. So why did it do that? This is not like some crazy HTML website. This is just vanilla code, right? That's being responded to from our server. So how do we interact with it? I made a request to my server by typing its host and port into my URL bar and hitting enter. That by default triggers what we call a GET request. We'll talk more about those HTTP verbs here in just a moment. But that's it. We navigated there, and it sent a response. It sent a plain text response, and that's all it does. Now from here, you could start coding out being able to write and handle the variety of HTTP verbs. And by those, I mean like get, post, put, delete, all those kind of crazy verbs that typically come from web-based requests. And also being able to combine like middlewares in between our routes. Like I have to have authentication logic that might happen before I get to a certain response that I want my server to send. All that kind of fun stuff, and like handling paths and matching paths and things like that. If I go to API slash pizza or API slash car or just forward slash is this cool with all hyphens or something like that. There's a lot of cool things you could do and you would want to do on a server, but as of right now, we would have to reinvent the wheel. We would have to code all of this logic ourselves. The functions of matching those HTTP verbs, all the logic of handling regular expressions or arrays or optional paths or route parameters and stuff like that. All these things that we would have to consider when building out a server are actually handled for us by a nice a nice web framework, meaning I want to add a server that handles typical web-based traffic using those HTTP verbs. I want to have logic built in for matching different paths in terms of top to bottom using regular expressions, arrays of strings, just a plain string value, optional path names, required path names with route parameters, and all that kind of fun stuff. So it will actually allow us to dissect what the heck is going on here. So ultimately, like I said, this is just a computer running some code that I have coded to simply send a response upon any request whatsoever. So that's all we built here, right? This thing, I send a request to it, it sends a response. But like I said, all that fun stuff of route pathing and verb matching and all the middlewares in between that's actually built for us by Express, which is fairly unopinionated as far as web frameworks go. There's plenty of them you can find out there. I know node.js is another very popular one that has a lot of built-in things for you. But in our course and this student, all they know is Express at the moment because, well, again, it's an unopinionated and very popular web framework for helping build out servers. So as you can imagine, the Express library just builds itself on top of this core simple stuff and extends it and gives us all those beautiful functions written already for us. So if this is what a simple server would look like, let's try and rebuild it with Express really quick. Okay, so I'm going to stop my application from running. I'm now going to use npm to install Express as a library into this project, and you can see that this will now appear in that package JSON right here. Under the dependencies list, we now see that Express has been installed and is now able to be imported and used throughout our application. We're going to import it the exact same way we did HTTP right here. I'm going to go ahead and just change the variable name to Express and change this to Express in my require statement. Configuring a full server with Express doesn't have us have this requirement of writing a response with a headers object and the text inside of it. We're going to be coding all that eventually. You can always change those values, but like I said, it comes with a ton of already built-in features that abstract this low-level stuff away from us. And making a server with Express, typically called an app or application or app shorthanded a lot in any code examples you'll ever see, where we simply invoke the entire Express library function, which will return to us an entire Express application built on that HTTP module. And now that app simply represents the whole application, and whatever we want to add to it, we can now do so. So instead of doing server.listen, all we have to do is app.listen, and now our Express server is listening on that. And then from here, they give you everything coded on the app as you need it, right? So if I write app. We'll probably get a whole bunch of crazy things down here. And yeah, we have tons of cool stuff our app can now do just given to us. And like I had said, we made a request to our server by typing in some kind of URL path into our Chrome bar right here, our Chrome URL bar. Hitting enter on it, like I had said, by default is considered a GET request to a server. Now, whether that server responds with an HTML page that looks all nicely built out with data on it, or maybe that it's just a plain text response that says, wow, this is cool, or maybe it's a JSON response, an object with a key value pair that says, wow, this is cool. It doesn't really matter. Ultimately, it's whatever you want it to respond with, it'll respond with. Now, granted, when you're talking about REST APIs or representational state transfer application programmable interfaces, REST APIs, basically it's like a guideline to say, all right, everyone's coding whatever they want, whenever they want, and it's making it impossible for anyone to collaborate easily because, again, it's like the Wild West. You can code the server to respond with whatever you want. But if you want to make it easy to interact with, like let's say I'm building a server that is made for a library, and I want people to be able to build their websites or applications off of my library database and server combo that I'm building out. It would probably make sense that I would document or follow a set of guidelines of, hey, this is how you should write your requests and how they are made, and this is how your responses should look in general, right? So while yes, you can make them respond with whatever the heck you want, you can follow REST API principles to kind of give you a more standardized approach and to also make it so other developers can help work on your project because, again, they can follow that same set of guidelines instead of just doing whatever you want, wherever you want. So we can actually now add and match any kind of verb we want, right? So from here, we can actually talk more about what a route is. I think I have a picture somewhere over here. Yeah. So again, ultimately, a route is nothing more than a combination of two things. It is going to be a HTTP verb because these are, as again, this is a web framework. The whole point is we are allowing web-based applications to make requests to our server. So the route is a combo of that HTTP verb, get, post, put, delete, etc., and a path. And that path can be a number of different things with Express because they allow us a lot of cool tools to write custom paths that have optional bits on them, required bits. It matches groups of characters, preceding characters. It's really cool, and I don't utilize it enough. And I know a lot of my students, this is going over their head when they're first learning Express, but I want to point that out here. Now, the action, the function that runs after the verb and path have been met is called a controller. Now, we don't go through this part in our course because we don't make them code insanely robust servers that require like a route or networking layer, a controller layer, and a model layer on top of that. We go over these concepts, but they don't have to code it out this crazy at this point because it'll be super overkill for an app that has 2 requests on it, right? But like I said, we have 2 things that build a route in particular. Our verb, in this case, we're doing get, because how do we interact with get requests? If you don't have a tool like Postman or something else, which the student at this point doesn't, they haven't learned that yet, then we are going to use get, because that is the type of request this URL bar, when hitting enter on, will make. We're going to write a path. What does the path have to be? Well, it can be the root path, aka a simple /. This / is just going to be the root path, localhost :3000. Right? It's the same path we had a moment ago. But we can also customize it. It really doesn't matter what you call these paths. They don't have to have some prefix like /API /pizza. But a lot of the times if you're coding out an application that has a front and back end in the same project, it would behoove you to probably put some kind of API prefix or some kind of prefix for your server-side routes to differentiate them from your client-side routes, not get confused. Right, that's all it is. It's a method and a path. Our route is technically done, but it probably should do some kind of action, right? Which is that function, sometimes called a controller, right? So we're going to have our request handler here. This Express calls it anyway. Like I said, it is a function, and you'll typically see it either through the function keyword or the arrow syntax, doesn't really matter, and you'll typically see it with at least a minimum of 2 arguments, shorthanded down to rec and res, standing for request and response. The request object, again, it's a giant JavaScript object, represents the incoming request to this route, which again is the verb and the path put together. If both of those are a match, it will run the following function or controller. Right? So the response is in Express for us is automatically coded with all those lovely headers and things like that, depending on what kind of response you send. It'll add a default status code, it'll write the appropriate headers for the response, etc. Again, it's nice that all this is already written for us so we don't have to write it ourselves, and like I said earlier, we don't have to reinvent the wheel. But what's cool about this now is that we can take this response object and send something very simple, right? If I don't intend to mess with the request object, like I don't care what the incoming request does, this is coded to simply send a response like yum, like that. That is good enough for Express. Like, that will take care of everything that we need to worry about. It will set up the headers for us. It'll send a default status code, etc., and it sends a plain text value of yum. And that's all we have to worry about, right? So that's what that is right here. This is our handler. Controller, sometimes it's called, when you see it broken down into larger scale applications. But ultimately, the route itself is the combination of that verb and string path right there. So, yes, if I now rerun this application by running node on server.js, we get the same output, server running on port 3000. I'm going to go over to my URL bar. We can either hit refresh or just hit enter again on that. And I did something stupid, which is good, because I can turn it into a learning opportunity. We got a response from Express here that said cannot get /. So there's that HTTP verb that corresponds with hitting enter or refreshing and making a request to a server. The type of verb it is, it's a GET request. And then it shows you what path it made the request to, which is a plain / path. But if we look at my Express server, I did not write any logic on what to do for that / path. I have a path called / pizza. So we got a 404 status code, which means not found, response, and it told us that it cannot get /. But if I now go to / pizza, I do get that plain text response of yum sent back from my server, which is pretty cool. That's all a route ends up being, and that is how you interact with GET requests. Now, you might be wondering, that's all fine and dandy, but what if I want to interact with it from my code somehow? What if I do have a website running somewhere or being even sent from this Express application? How do I interact with that? Well, let's go ahead and code out a client folder. It can be also public. It could also be pizza, car. It doesn't matter what you call the folder, as long as you just know what it represents. This is going to represent my client-side website. It'll have an index HTML that will use a shortcut here. My super cool pizza site. I'm doing just a pizza kind of day. I'm going to add an app.js. No CSS today, yo. None at all. Okay, there's our app.js. It's going to be coded along with it. We'll do a quick console log test in my application here. Now that that's done, how do we set this up? Well, we can code our Express application to send what are called static files, right? So what it can do is we could write a bit of code on our Express server that will take a request and send a response. That's, as you can see, that's like what we're building up to here. And this is actually a middleware that's added for us. And by static, it means unchanging, because once these files are written and sent to the browser, they're clearly not changing themselves, hence why we're going to call them static. So to do that, we can write the following bit of code. We can say, hey, Express application, I would like to use a new plugin. And these plugins are called middlewares in Express terminology. So this middleware we're going to be adding is built into the Express library itself, and it is called .static, right? This is a built-in middleware function in Express. It serves static files and is based on serve static. Okay, this is a function, as most middlewares will be, right? And here's where we need to provide a root string and some options if there are any, meaning, hey, where is this static directory or file found? We are simply going to write, look for the client folder, and if I don't provide any kind of leading /, we're not going to be doing up one directory, down one directory, anything. We're not doing like relative pathing. If I just write the name of the directory in the root of the project, so make sure your client folder is not nested anywhere. If I just name the directory in the root of the project, that's where it's going to go look. It's going to go look at the root of my node fun directory, the project we're working on here. It'll find that client folder and it'll send the static. And I don't have to write /index HTML because index files are entry points for directories. This is like really newbie terminology. The client folder has an index file, and that's what's automatically going to be found and sent. That also means that anything attached to the index HTML, for example, the app.js, will also be sent. So let's go check out what that did with this code base. Now, you know, until you learn about NodeMon, you have to stop and restart your server every time you change code and save the file. So from now, it will still respond with yum on /pizza, but now if I go back to that root path of just a simple localhost :3000 / or no / it's the same thing, and hit enter, we see my super cool pizza site has now successfully loaded, and we also see the console log, wow, coming from my application, my app.js, right? So the whole purpose, it's a dolphin joke here, the whole purpose of this is to, again, the student might be wondering, well, that's all fine and dandy if I hit /pizza in my URL bar to interact with this route, but how might I do that programmatically? We will do that now by, I'm going to close out that server file because we're done working there. I'm going to close out the HTML. We're done working there. I'm going to replace this console log with something else. Now, if you're using, for example, jQuery, you could use the jQuery Ajax function to achieve it. You could also just use the built-in, because now we're in the app.js world, right? The app.js represents the JavaScript runtime environment in Chrome, Firefox, wherever browser. And most modern browsers are come included with a library or a function called fetch. Fetch will do, surprise, HTTP requests. We happen to have an HTTP framework running on our server, and all we have to do here is write the path to it. Now, we could write localhost :3000 /pizza, but we can actually get away with just writing /pizza because this website is running at the same port location as our web server, right? Our web server is running, and our website is loaded on localhost 3000. So because they're in the same port and location, I do not, or host and port, I do not have to write the root URL of localhost :3000. If I was running this web app somewhere else, like out of a different project and loaded in a different way, I would have to include the full URL name, and that'll also come with issues with CORS, or cross-origin resource sharing. If you want a video about that, let me know. By default, fetch will make GET requests unless otherwise specified. So it will default to the HTTP verb GET, which works in our case because we have a GET request coded to /pizza. Then we can get a response from said server, and we can take a look at the response because we're expecting it to be, well, yum, the plain text of yum. But if we refresh the page to, and again, if you're wondering, oh, but Luke, you changed some code. Don't you have to restart your server? We did not change server-side code. We changed client-side code. To reflect changes in client-side code, you refresh the website, and there we go. So fetch, by default, will have this as a response. It will have a response that basically tells you some metadata about, hey, the server sent a response, or the server didn't send a response. If it sent a bad response, for example, 404, not found, it will still be a response according to fetch. So you would think it might throw an error in our promise chain here, where I'd have to write .catch to catch an error. It's not the case. Any response, good or bad, from fetch requests is still a response, and it leaves it to you, the coder, to handle if it's a bad response. But in our case, we're fine in saying, oh, look, it is just a good response. This OK Boolean is a quick way to determine that. Our status codes of 200 to 300 value ranges are typically OK, and 400 and 500 ranges are typically bad, which would get an OK false. But again, it's a response, and we are left ourselves to parse that response to do with what we want. Meaning, we have to use some properties built onto this response object from fetch that give us the ability to, I wonder if we can find them. I was hoping that I could poke around and find where my readers are. If I could find like .json and .text and stuff like that. C'est la vie. But either way, that's what this response is. It just simply represents whatever our server sent back to us, right? And like I said, there's our headers, right? That headers object that has key and value pairs on it, where we can find what kind of headers came with this thing that Express has sent us. But like I said, that's all the response is. This is an object that got sent back from our Express server. And again, look how much stuff was added to it, right? So our response has, and it should have, a .text promise, right? This says, hey, I will take this data streaming in with the response, its body of text, and I will parse it into text for you. So it converts it from whatever data it's streaming in with fetch to this response here, and it's going to return it to us as a promise, right? And so because it's a promise, I have to let it resolve. Now, don't fall for the .then chain like this, because you're going to create that pyramid of doom effect over time. You can actually just return a promise from within this .then, and if we return the promise like that, it allows us to daisy chain the .then on the outside and not create that pyramid of doom effect going inwards, right? And all I have to do here is remove the keyword return, drop my curly braces, and I can now do a one-line arrow response, and that's what that is right there. That's what that implicit return does for us. And now I should have whatever my server's response was. We can call it res again. We could call it whatever, like text or body that is sent from the server. And I can now console log that to see if this resolution worked or not, right? So the code has been saved. Refresh the browser and check it out. There is us interacting with our server from our code. And from here, you can take this body of text, this variable body represents a plain JavaScript string. And what you could do from there is, well, anything you want. I could take it and put it at the end of whatever this text is right here. We can use any vanilla DOM we want to manipulate this text. So I can say, hey, I would like to create an H2. We'll say document.create element of an H2, h2.text content equals whatever the body came back from the server. And then I'll say document.body.append a child and append a new child H2 to the document body. There we go. Cool. And that's all it is right there. That's how you can interact and work with a HTTP server from our website code. So hopefully that cleared up a lot of y'all's questions for Node, Express, and, well, what is a route? Yeah, and if you're out there doing server-side interviews, even this fundamental stuff is important to know how to, well, explain to your interviewer, right? And I will make a note that I think that lab the student is on, ask them, no, this is fine. Yeah, so this is, I'm not going to bring in jQuery to this whole mess here. I think learning how to do it from fetch right here is fine. If you want to configure it to your AJAX request, then, you'll use some documentation examples to get there. But this answers the core of the question of what is a route? What is the response supposed to be? Again, whatever you want, whatever it needs to be. Theirs was specifically how do you read a file, so maybe I'll extend this video a bit further to do that. But I think 30 minutes on what is a route is good enough. So then again, ultimately, what is a route? Is this combo right here, the verb and the path. It can be whatever you want. And then you send a response, whatever it needs to be. And then you will make a request to that route and verb combination. In terms of fetch, now this is not, again, if you're using Axios or Ajax, you don't have to do this. Their steps are a little bit different in how it's handled. But in terms of fetch, you get a response, whether it's good or bad. From there, you handle with conditionals. If the response is bad, go here. If the response is good, do this. We're just saying whatever. We're going to assume it's good. The response object with fetch comes pre-coded with several parsing tools. It's saying, hey, I have some body response data coming in, and you are responsible for parsing it for whatever you're doing. So we know we are sending plain text as a response, which means we use the .text function, and then we take whatever that parse data is, and from there, do something in code or manipulate it in your code, then display it. It doesn't matter what you do with it. In my case, I just chose to display it directly inside of an H2. Before this video ends, a lot of my students will always see this more commonly. You will see res.json. Res.json is a send. It's just specifically sending JSON data, and it will provide the appropriate headers for that as well. So it's a send, a specific kind of send, because send could be a page. It could be HTML page. Like you could write HTML directly in a send. We could do plain text like we saw here, or we can do JSON. But if we're going to be talking about REST APIs, the majority of the time you will see JSON-based responses from REST APIs, typically objects with key and value pairs, right? We might say, like that, we'll have an object of property text and value yum now. So what does that change on my client-side code? Well, I changed server-side code, which means we have to restart our program here. Head back to our app.js for our client-side code now, and this promise will change from text to .json, okay? Now, that's built onto the response object from fetch, okay? Like jQuery, Ajax, and Axios will automatically detect what kind of body of data you have and parse it for you, whereas fetch does not, okay? And it does that, the other libraries do that based on the response's headers. What kind of content type is coming with this response? Is it plain text or is it application JSON data? Since it's JSON data, body now represents this object of text yum. So we now have body.text to get the same value of yum appearing in our code, right? So body.text. That represents the body we have parsed. Body.text is how we get the value yum. And let's do like more exclamation points here so I can make a difference. Stop the server and restart it since I changed that code. Back to our browser and voila. So yeah, like I said, I didn't think I would spend 35-ish minutes talking about something this simple, but I realized there's a lot of fundamental ground to cover, and I wanted to make sure the student and anyone else beginner-wise watching this video learned a bit more about Node, learned a bit about web frameworks and why Express is so popular and fun, how Express code will be built on top of that Node HTTP library, how it provides a lot of out-of-the-box configurations that make our lives as web framework server developers super simple and super easy. If there is interest, I'll be happy to do another video going further into the cool things you could do with route pathing, because there's a lot of cool stuff you could do with that. And I can even talk about a more common approach you'll see where individuals will move this out, let's say, to a different file entirely. Where they will do the following. We'll call it like that. They will have a file or directory for what are called controllers, aka the actions that run on endpoints or routes, right? An endpoint route is one that sends a response, because you can have routes that don't send responses that do something in particular. Again, that's more advanced stuff for a separate video. But you'll typically have things like this where pizza controller, oh, dang it. All right, hold on. I had to make things as confusing as possible. There. This is something more along the lines of what you might see in a bigger project, where you'd have something that looks like this, pizza controller.getPizza. This is something you'll commonly see in big scale projects, because you might have 100 different routes. So you'd have a file that handles the application's requests with their verbs and their paths, because that's the route right there. This is think of them all being different in a big scale project, and having all of your function code in the same file will get very confusing and hard to read. So you might have one file that is specifically dedicated to handling a route's path and verbiage, and then you assign to it code written elsewhere its controller, the action that will ultimately send a response at an endpoint, right? And then you'd go to a different file where you'd find your controllers, a collection of functions you export out of that file, and then you combine them to your route up here. So that's another common strategy you will see. And again, this is totally overkill for as simple as this project is, but I wanted to give you all an example of what more complicated Express structures end up looking like, because I didn't know about this when I was but a wee noob in Express and things like that. And when I first saw someone's like large scale Express project, I'm like, what the heck are controllers? I just thought it was going to be a verb, a string, and a function at the end of the day, which again, that's all it is. But when we abstract things out into multiple layers, we would call this our my networking or my routing layer, and this would be my controller layer, right? So that's where you see those terms come from. So yeah, like I said, wanted to cover these fundamentals. I thought it was a great question that student asked, and I thought it warranted a long, fun, meandering path of a video. So if there's interest, get in the comments below if you want some more advanced Express stuff. I'll be happy to throw it up there. Otherwise, check out my Building a Full Stack CRUD App from Scratch series, where I do build out an entire Express server and talk more about this stuff in depth and give you all some examples where we code out a server for taking a note-taking application. I also have a solid Express server starter series you can check out on our YouTube channel. The links will be in the description below. Make sure to like, comment, subscribe, and read that description and check out how you can get involved in our Covalence Discord community. So bye for now.